All right, let's talk about electric vehicles. We all know the usual pitch, right? They're clean, they're quiet, and they're supposed to be this huge leap forward for the planet. But what if I told you that the solution to pollution from the tailpipe was creating a totally different, kind of hidden problem? Yeah, it turns out there's a lot more to this story.
So that brings up the big question. Are EVs really the perfect, flawless environmental solution we've all been hoping for? I mean, the common thinking is, yeah, of course. But the real story has a surprising twist, and it has nothing to do with the engine or how it's powered. It all comes down to simple, boring weight.
But hey, first things first, let's get one thing straight. The big win with EVs is absolutely real. A gasoline car pumps all sorts of gunk into the air we breathe. An electric car, nothing comes out of a tailpipe because there isn't one. And for air quality in our cities, that is a huge, undeniable victory.
However, and there's always a however, isn't there? There is this hidden catch to this otherwise brilliant solution. It's an unintended side effect that, again, has nothing to do with emissions. It's all about something way more basic. Just how heavy these things actually are.
Get this. On average, electric vehicles are a whopping 20 to 30% heavier than the same car with a gasoline engine. And we're not talking about a small difference here. This is a fundamental change in the kinds of vehicles that are driving on our roads every day. So why? Where's all that extra weight coming from?
Well, the main culprit is the very thing that makes an EV, the battery. I mean, think about it. To get a decent driving range, you need a ton of battery cells, and those things are seriously heavy. And then you've got to protect that giant, expensive battery in case of a crash, so car makers build these heavy-duty, reinforced cages around them. It just all adds up.
And let's put that into perspective so it's not just numbers. An electric Mini Cooper is carrying an extra 115 kilograms. That's like you've just done a massive grocery run and it's just in the car forever. But then you look at an electric Maserati, it's hauling an extra 465 kilograms. That is literally like driving around with a whole other adult in the trunk at all times.
Okay, so you're probably thinking, all right, they're heavier, so what? Big deal, right? Well, it turns out our roads care a lot. That extra weight has a direct and, frankly, a surprisingly powerful impact on the very ground beneath our tires. We're talking about our entire road infrastructure.
The basic physics here are actually pretty easy to understand. Just picture yourself walking on a sandy beach. If you're wearing flip-flops, you barely leave a mark, right? But if you're stomping around in heavy work boots, you're digging deep into the sand with every step. It is the exact same principle for cars on pavement. More weight equals more pressure, which equals more damage.
And this isn't just a nice little analogy about the beach. This is backed by a real scientific principle, and it's called the fourth power law. Now, the key word you need to know here is exponential. It means that a 20% increase in weight doesn't just cause 20% more damage. Oh no, it causes way, way more. So, when you actually apply that law and do the math, the result is kind of startling. An average EV can cause around 50% more wear and tear on our roads than a comparable gas-powered car. 50%! That's a massive difference, and it all stems from that extra battery weight. And, the inevitable result of more road damage is, well, it's exactly what you'd think. More potholes, more cracks, and a constant, really expensive cycle of repairs. Let's just say our road crews are about to get a whole lot busier.
I love this quote from the source material. It compares the process of making asphalt for road repairs to baking cookies. It's a big industrial process that burns a ton of energy and uses a lot of heat. But unlike baking cookies, it releases a whole lot of pollution.
So let's connect all the dots here. It's a domino effect. 1. Heavier EVs cause more road damage. 2. More road damage means we need more repairs. 3. Those repairs need asphalt. And 4, and this is the incredible irony, asphalt is a petroleum product. It's made directly from crude oil.
And that brings us to the really wild, unintended consequence here. The very technology that's designed to get us to use less oil is indirectly making us need more of an oil product to fix the roads it's damaging. It's this hidden feedback loop that suddenly makes the simple EVs are good for the environment story a lot more complicated. But look, this isn't an unsolvable problem. It's not doom and gloom. It's an engineering and policy challenge. So the real question is, how do we solve this heavy problem so we can pave a better future?
It seems like there are three main ways forward. First, and this is kind of the holy grail, is to develop new battery technologies that are just plain lighter and more efficient. Second, we can attack the problem from the other side by engineering stronger, more durable road surfaces that can handle the extra weight. And third, we can get way better at recycling the asphalt we already have to reduce our need for new oil.
So, the crucial takeaway here is not that EVs are bad. It's that we need to be really smart and think about the whole picture when we make the switch. You know, it's like planning a big trip. You have to think about the entire journey, not just how fast you can pull out of the driveway. We've got to consider all the consequences, not just the obvious ones.
And really, that leaves us with one last big thought. This whole story shows that even our best, most well-intentioned green solutions can have these hidden costs. And it just makes you wonder, what's the next unintended consequence we need to uncover before it's too late?